Alright, this is the second video for day 38, and we had just talked about what proportion of bags will have fewer than 525 M&Ms. In the past we would have done it finding a z-score and looking it up on the table. We can still do that, that part works, but now we are learning how to use our calculator to do that. So here's some notes down at the bottom. Using the TI-84, you use the normal, go to second distribution, normal CDF, type in your lower bound, and basically when you're dealing with, when they say lower bound and upper bound, you've got your normal distribution. Okay, your normal distribution starts at negative infinity and goes to positive infinity. So a lower bound and an upper bound, typically sometimes the lower is negative infinity, upper can be positive infinity. You could start at an actual value and end at a value. So you've got your lower bound and upper bound. So whatever area you're shading, so if you're shading from here to here, this would be your lower bound, upper bound would be here. And then you type in your mean and standard deviation for whatever situation you have. Lower on the left, upper on the right. Okay, it gives you area under the curve bounded by the lower and upper bounds. If you don't enter values for mu and sigma, it will assume you're just using 0 and 1, so it'll give you a z-score. So to find, we just did this, so find the probability or the proportion of bags that are less than 525, which on our picture, the first time I did it a little wrong. The 525 is way down here. So there's 525, somewhere way down there, so it should be a very small percent. You're going to enter normal CDF, negative infinity, which we typed in is like 4, not 4 or 5 nines. Just make sure there's more nines than however many digits in this number. 525 was the value we wanted to stop at. Our mean was 550, our standard deviation was 12. And we got a value of 0.0186. If you look it up on the, if you find the z-score and you look it up on the table, you get 0.0188. That's the differences in the last assignment. Your book was doing it using the calculator and you were looking it up. So to get full credit on the exam, you must define the variable. So we would say x equals the number of M&Ms in a 1 pound bag. Okay, you have to define the variable, state the distribution. The distribution is normal. Okay, n. So x is approximately normal with a mean of mu comma sigma. So x is approximately normal with a mean of 550, comma 12. So that's how you name the distribution. So define the variable, 1. Name the distribution, 2. Sketch the picture. We did that way up here. There's the picture, 3. How you got the, state the question. Here's the question. And how you got the answer. There's how I got the answer. And the answer. So you have to state all of that to get any credit. So just writing this down, no points. All right, so let's answer more questions. So what proportion will have fewer than 600 M&Ms? So we're going to name our distribution. X equals the number of M&Ms in a 1 pound bag. Okay. X is approximately normal with a mean, that means approximately, with a mean of 550 and a standard deviation of 12. The first number is always mu, the second is sigma. I'm going to draw myself a picture, same picture we had on the last video. The mean would be 550, and then each standard deviation mark I add 12 to go up, and subtract 12 to go down. I put my mark 60%, an eighth of the way. All right, so there is my normal distribution. So for this first part, we want to know what proportion. So the probability that x is less than 600 M&Ms. So we're doing, this is everything you have to do on every problem. Now, I can shade this in for each, I'm going to just shade it in for each part. So 600 would be like way up here. So here's like 600, and I'm looking for everything over there. So this is what's going to help you decide what your lower and upper bound are. So now, to type this in your calculator, you're going to do that normal, CDF, lower bound, comma upper bound, comma mean, comma standard deviation. That's what you type in. So we're going to go to our calculator. We're going to type in second distribution. second distribution, normal CDF, it's the second one. My lower bound, if I'm everything over here is negative infinity. My upper bound is 600. My mean is 550. My standard deviation is 12. I hit enter again, and that gives me 0.999. 0.999. So virtually 100%. Okay, so pretty much all bags will have less than 600 M&Ms. Virtually all bags will have less than 600 M&Ms. All right, so now we would like to, we've already named the distribution. Here's our, defined the variable, named the distribution. We have a picture. This shading went with less than 600. Here's the problem. Here's how we got it. Here's the answer. So now we're going to do the same thing here. X, we've already got this written. We've already got this written. We've already got the picture. So we need to write the problem. What proportion will have more than 565? So X is greater than 565. Now the way we would have done this before is we would have had to say 1 minus the probability that X is less than 565 because our normal distribution only does less than. But now, if we just look up here, where's 565? So here's 565, and we want more than that, so we're shading up above. So this is the picture of what I'm finding for this probability. So if I look at my lower bound is the 565, and my upper bound is infinity, or a bunch of nines, at least 4 nines. So now we can just do our normal CDF, and my lower bound, comma upper bound, comma mean, comma standard deviation. So that will be my lower bound, this time is 565. My upper bound is infinity. Mean is still 550, and standard deviation is still 12. So if I type that in my calculator, second distribution and CDF, this time I'm starting at 565. My upper bound is infinity. My mean and standard deviation are the same. It gives me 0.1056, 10.56. All right. What proportion will have between 530 and 570? So the way you write this as a problem, you could just write words like BETWEEN, 530 and 570, but the inequality way that we write this is the probability that X, my variable that I'm looking for, is in between the smallest and the biggest, and then I just write less than symbols. That's the mathematical way to write that. And if I look at my picture and I draw this in my picture, 530 is about right here, and 570 is up here, so I'm looking for this shaded portion in here. So that means 530 is my lower bound and 570 is my upper bound. So to calculate this, I'm going to do my normal CDF. My lower bound is 530, comma, my upper bound is 570. My mean is still 550, and my standard deviation is 12. Again, this is lower bound, upper bound, mean, standard deviation. So I type this in, second distribution, normal CDF. My lower bound is 530, my upper bound is 570, my mean and standard deviation are the same, and I get that that proportion is 0.9044. So that is a pretty big proportion that I just shaded in there. All right, so now we're doing backwards. We did these before, like when we had the 90th percentile, the 70th percentile, 75th percentile. What is the 30th percentile? So what we would have had to do is find what z-score goes with 0.30. And we'd have to look up the closest value to 0.30 and find the z-score. Well, our calculator actually has a command called inverse norm, and it's described right here. So inverse norm is the first number you put in is the area to the left, so that would mean whatever you're shading, you know, even if you're trying to find up here, you still have to do to the left. You still have to do to the left here, area to the left, then the mean, then the standard deviation. The area is the percent. Area is the percent that you're given. So the 30th percentile, this is the area. So the 30th percentile, you have to think of where it's at, because if you're looking at the 80th, well, the top 20%, you have to think of it differently. But here, the 30th percentile would be down here, 30th percentile. Okay, so you're going to type to the left of that. So you're going to type in 0.30, and then your mean is 550, and your standard deviation is 12. So inverse norm finds what number, how many M&Ms at 30th percentile, 30%. So what would be the number down here at the bottom? If you go up and look up here, what would the number be that represents the 30th percentile? So we're just going to go to second distribution. So second distribution, the inverse norm is the third one. And I'm going to type in the area, which is 0.3. My mean is 550. My standard deviation is 12. And it gives me that would be 543.7 M&Ms. That would be the 30th percentile. So that's the direction here. So to find the 30th percentile, there it is, typed in. All right, so next page. A few more questions. What is the interquartile range for this distribution? Well, that's kind of nice. We just need the 75th percentile. So we need the 75th percentile minus the 25th percentile. So we can do inverse norm, 0.75, comma 550, comma 12. The area to the left is 75% minus the inverse norm of 0.25, comma 550, comma 12. So second distribution, I'm going to do, and I can actually, well, inverse norm, 0.75, 550, okay. That gives me 558.09 minus. Now I'm going to do inverse norm, second distribution, inverse norm, now with 0.25. And that gives me 541.91. So now I just subtract those. And I get that the IQR is 16.18 M&Ms. All right. The company wants to guarantee that no more than 5% of bags have fewer than 40 M&Ms. What mean should they try to achieve, assuming the standard deviation is 12? All right, so this time we've got our scenario. We basically want to change things a little bit. So we want to guarantee that no more than 5% of bags have fewer than 540 M&Ms. So 540, so basically wherever 540 is on here, what we want below it is 5%. Okay? So what we want below it is 5%. So we are going to need to figure out what mean we want. So we're looking for the mean if we're going to keep our standard deviation of 12. So in other words, we need to figure out what z-score goes with 5%. What z-score goes with 5%, and we can actually use our calculator, our inverse norm, to do that. So inverse norm, 0.05, comma 550, comma 12. So second distribution, inverse norm, 0.05, okay. So it gives us that, well, it actually gives us the value that goes with that is 530 M&Ms. So I don't think that's going to give us the thing that we need. So let's start this problem over. We basically want 540, yeah, I think we're kind of doing okay. But let me just finish problem 8 and 9 on the next video. So sorry about that. We'll have one more video for this.